Alright, we've got another radio here. Another one out of the attic. Been up there for many, many, many years. It is a CROSLEY mini bandbox. There's two versions of this. One of them is about another few inches larger, and this is the mini version of it. This is much more rare than the full-size one. Okay, we got trouble with it. One dial is smashed. Those do things. Okay, those are okay. But we are missing the dial here. Okay. Boy, it's in perfect shape. I mean, it just, the cabinet is perfect. Doesn't need to be refinished or painted or anything. All right. The labeling for the wiring. Okay, we got tubes. Okay. All right, it's a battery set, 01A type battery set. 71A for the output. Aha, here's our dial. Okay, oh my. It is broken. It is big time broken. All right, 01. 01. 01. So we got a bunch of tubes. Maybe good, maybe not. 5-tube battery set. Internally, it is absolutely clean as can be. But we have got a serious, serious problem. That problem is this variable tuning condenser. Let me see. I mean, it is all but frozen solid. I mean, it is absolutely. This is made out of pot metal. And the pot metal swells, causing the plates to separate. You see here, this insulator is cracked because this piece of pot metal here that was cast has swollen, and it just literally forced those two holding nuts apart, and it just ripped that piece of Bakelite. Okay, so what we're going to have to do, we'll have to get this thing out of here and work on it. Get it to where it's completely free turning, and we'll have to find out what we have to do to get this bracket. We have to see the pot metal just completely crumbled here. It the gear is still intact, but the that'll come right off of there. Yeah. So this part here is the bearing, and it has completely broken off down inside there. So that's going to have to be repaired. Going to involve machine work and stuff like that. But the first thing we got to do before we can do anything, tuning condenser has to come out of there. I'm going to just force upwards. Okay, a little more. Okay, very good. Screws and nuts. Oh, that is really fine engineering there. Okay. Oh, it's been worked on. Look at that. It's been worked on. Got a grid leak. surface cement there to hold that back on there. Okay, so that's a pretty good indication that this radio is probably in working order, other than that tuning condenser being screwed. Okay, first thing we've got to do, pull these wires. All right. Okay, that gets it to where it's just hanging in there. Here. Okay. It is definitely tight. Okay, I can tell that one there is touching. All of these over here are touching because this is swelled out. Okay, that will come out of there. All right. Okay. Incredibly, that thing is still intact. But the main thing now is we have got to get this thing to where it rotates freely, completely, totally freely. It's just absolutely okay, we'll get this out of here. Okay, that's what puts pressure onto here. Okay, we can get all of this out of here. Okay. Okay, I'm going to use this to serve as a handle. Okay, it's jamming. This plate is jamming on those things. See, it's swollen up. That's supposed to have a little bit of clearance for that plate, but it's jamming. That's causing it to have tightness. All right, let's get that out of there. Down. Okay, that's loose enough now. Okay, is that an even size? It does not look 1/4 inch. It's 3/12. Okay, I've got a reamer for that. What I'm going to do is take these, and I'm going to run the reamer through there so that this will just slip onto here. You see, it's got a little bit of a bend to it, which makes it to where it jams onto the shaft. This one's okay. See, that's just beautiful there. But this other one's tight on there. Okay. Now there's not a thing we can do with these, okay? Now what I'm going to do is I'm going to take this plate, I'm going to grind that out a little bit inside there. And that'll make it to where these things don't jam on it. Okay? Okay, there's nothing we can do with this here. I mean, it just, the stuff is swollen and there's not a thing we can do. It's tight and strong. You know, we can just leave it the way it is. Just not messing with it is the best thing. Okay. The frame itself is completely intact. There's no cracking or swelling. That's weird. Different type of pot metal. It's just these rotors. If you look at those, wow. Just see, it's got a curve to it, so it makes the plates to where they're at a slight angle, and that means they'll, if you adjust it to fit one side, it touches on the other, and if you you know, there is another possibility is just to jury rig another tuning condenser. We get a standard tuning condenser and we jury rig it into there. But that ruins the value of the radio. This is a $500 radio when it's completely restored and working. So I don't want to ruin it. I want to keep this thing completely original. Okay, I'm going to go out and run the reamer. I don't think I have to. That's okay. I don't really need to run the reamer through them. They're doing okay. They're okay. That's okay. The main thing that has to be done is this has to be opened up so that we don't have that jamming on the bottom. I'm just going to open it up about a 1/16 of an inch more, and that'll make it to where it doesn't jam. Okay, you can see that is completely swollen and just totally demolished. And it was what, let me see if I have that little piece that went. See, what that did was it held this right here for the knob shaft. So you know, this is completely demolished and disintegrated and turned to junk. So we're going to have to machine one of those. Not going to be particularly difficult, but it's not. The main thing is, look at that. Look at that. The stuff's just crumbled. It just absolutely just crumbles. Absolute junk. Okay. First thing we're going to do, get the condenser. We have to have the condenser in place so that we can get the exact position of the gear. Then we plan out how we're going to make the little adapter to hold the shaft in place, the tuning shaft in place. Alright, I'm going to go clean this up and then we'll be ready. Alright, I just took a rat tail file and ran it there to open that up about a 1/16 of an inch more. Okay, so that should fit very nicely now. Okay, this goes back in there. Now, this is swollen up enough to where when this is centered in here, we're touching the end. So I have to grind the end of this off so that it's going to fit. Okay, now what about the other one? Okay, this one here we'll have no problem with at all. It can go. It goes like that. When that's in the right place, this one's jamming, so I've got to grind that one off. Looks like about, it's a bunch. It's a bunch. I'm going to have to go almost up to that set screw. That's really bad, but there's nothing else we can do. Worst comes to worst, we may have to make a collar to go on here to put a set screw in. That can be done, but we'd like to leave it just alone. Okay, I ground off here and ground off here. Okay, it goes in there like this. Still not going to make it. Okay, I'm going to have to take some off of here too. I can't take any more off of here because this thread on this set screw, you know, I'm going to go into there, and if I tighten it, it's going to shatter the whole thing. So we're going to have to take some off of here too. Now, we're going to use this sanding drum, and we're just going to take it and sand that off by about a 1/16 of an inch. Okay, this is at a slight angle. I've got to go grind a little more off the bottom of that. Okay, now I'm going to go fix this, and that should fit. It should work. All right. Okay, that looks extremely good. Okay. We now have complete clearance. Complete clearance. It's not touching anywhere. Okay. All right. This one here, it goes like this. Okay. Now, before we do anything with those, we put this back together, okay? This thing goes back into here, like that. Do that. And we need to lock it. Locks the shaft into place, okay? The shaft is in place now. It turns completely freely. Okay, now that gets put onto there. Okay, now the shaft is locked in place now. The spring tension on there holds the shaft. So the next thing that we have to do is position these rotors to where they don't touch anywhere, okay? Okay. We're very good. Okay, these 7 are really good. We got 4 right here. They're a little bit of a problem, okay? I need a deal. Okay, I'm going to take this one, bend it in. Okay, and then here, boy, that looks good. Okay. I gotta take that one, bend it in. Okay. Take that one. Good. See, these outside ones are the ones that swelled out. So what I've got to do is bend them in so that they don't touch. Okay. Boy, that feels good. Okay, I'm gonna hook a meter onto it. Okay, this one's perfect. I mean, even looking at it, it's very good. I mean, if you look carefully, you can see how nicely they're lined up. No. See, they're just very nicely centered. Now, we look at this one over here, though, and we see that one's tight right there. Other than that, they're tight because it's over a little. I have to still set this one, okay? Okay. Okay, that is over as far as it's going to go. And I have to have it in the same position. Both of them in the same position. Okay. Now I tighten it down the set screws. Okay. Okay, something is touching right there. It's this plate. Let me bend that over. There we go. That plate was just touching that set screw. Okay, now I need to just bend these a little bit, okay? The outer three have to be bent over just a little. Beautiful. Over here. I hear something touching. All right, let me look underneath. Okay, I've got one touching right here. Okay, we have to take I want to take the second one in on both of them and bend them inwards. Bend them this way. Second one. Okay. Now. Beautiful. Absolutely beautiful. Okay, now on this one, I need 1, 2, 3, and 4 have to be bent this way. 4 of them have to be bent that way. Okay, that's number 4. 3, 2, and 1. Okay. Whoo! Boy, that feels good. Okay, this one. Okay. Okay, number 5 has to be bent. 2. 1, 2, 3, 4, 5. Bend over. Okay. Beautiful. Okay, now we have, okay, that makes them okay on the bottom. And then the top, okay. Now, I've got to take, okay, let's see. Here, I have to go this way, this way, this way, that way, and there. Okay, now. Oh no! The pot metal broke. Oh, 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 oh. Oh, disaster. Okay. Oh, damn, 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 damn. Okay, now what I'm going to do, I'm going to take epoxy and right across the bottom there, I'm going to put epoxy. stick these pieces of wood on there, and that's going to hold those in position. Okay. That is absolutely perfect. Yeah. Looks good. I'm going to make darn sure I don't get this stuff on the plates and glue the plates together. Oh, that'd be just wonderful. That is really good. Okay. Real good in position. Okay. Now. Okay. Okay, it's absolutely positioned correctly. I'm just filling that crack. Alright, it's perfect. Now, everything's in position, epoxied. You know, sticks down in there? Okay. Alright. Okay, we're going to let that harden. It'll take it about 15-20 minutes to harden. Okay. That restores the condenser itself. The next thing we got to do is the mechanical work to get the gear drive. Okay? Now, this thing is going to be on here. Okay. I don't want to lay it on the condenser until this epoxy is completely hard. It's still too soft. Okay. I'm going to leave it go overnight just to make sure. I mean, it's just too perfect to screw up. Alright, it's been overnight, and this is absolutely solid. The epoxy's hard as a rock. I mean, this thing is perfect. Okay, that's good for another, I don't know how much more this stuff is going to expand. See, that's all down in there. It's just solid as a rock. That'll just hold those plates in place. Okay, let's get this back in there and we'll get busy at the mechanical stuff. Okay, alright, that's good. See, now this other part goes down here. We have this that goes on there, and then that gear has to be supported in such a way that it turns it, which is going to be quite a trick. Oh no, come on, don't do that, don't do that. Don't hold the plates. They're going to slide on the... Okay, now that is correct. Now that has to be supported right there. Boy, that's going to be a trick to do. Okay, let me get some measurements here. Okay, now what I have to do is measure exactly where this is with respect to the center. See, this has to be right here. Okay, in a center line. I would say it's an even 2/10. So the distance between the mounting holes, okay, it's 0.87. The overall diameter will be, all right, 1.3. Now the height up, we got to measure the height up from the panel to where the gear is going to sit. Okay, that will be 0.75. So we're going to come back in here and we're going to come up. Okay, so we have to counterbore inside 0.9. Okay, and the hole, 1/2 inch hole. Okay, we can make a 1/2 inch hole, and the total will come out to 1 inch. Okay, the total is going to be 1 inch. So here's what we're going to make. We're going to make a cup. It's going to be circular cross section, overall 1.3 in diameter, and we'll have our 2 mounting holes on the sides at 0.87, and then we're going to counterbore it by 0.9 inches, and then we'll drill our hole 1/4 inch, I'm pretty sure. Okay, 1/4 inch hole for the shaft, and then that will support that there. Okay, and then what we're going to do is we're going to run the milling cutter across here, 0.26, actually 1/4 inch. Okay, now what we'll do to support the bottom end of the gear, we'll make a plug that fits up inside there like so, and we'll just go into the side with a screw, and that'll support the back end of the shaft. See, and this plug will be pressed into there. It'll be a 1-to-1 fit up into the hole, the 1/2 inch hole. Alright, first we're going to cut it to 1.3 diameter. Go down to 3/4. I'm going to just make it an even 8. Now I got to make sure we've got clearance for the screws. No, we can't do this. I've got to go much smaller. Got to go smaller. 87. Okay, we're going to have to make that. We're going to have to take that down a bunch more. We need to go to 0.7. All right. Now that gives us our basic outer shell. Next we have to go through it with a 1/4 inch hole. Next we have to chop it off to 1 inch. see a dumbbell and pick it up. It's probably red hot. All right, now we have to go up in that way with a 1/2 inch hole. You got to go 0.9 inch. So we got a taper in there that's 1/10. So we go 0.8 inches. Sometimes things work, sometimes they don't. I'm gonna go in with a milling cutter. It's going in off center. I thought that 1/4 inch hole would be enough to pilot the thing, but it isn't. I'm going to go ahead and clean it up with a boring bar. All right. That gets our hole 1/2 inch, 0.9 inch down in. Okay. Now, this gives us the housing. Okay. Now, let me go get I'm going to go get the shaft to make sure it goes up in there right. Okay. See, that goes right in there. Okie dokie. That looks very, very good. See, now we're going to make a plug that goes in there that has the diameter of this end of the shaft here, and that'll support that end. And so between the two, that'll keep it in there. And then we have to mill a slot in there so that we can get the gear to touch the pinion. Okay, the next thing we need to do is make the plug that goes up in there. All right, we're going to make the stub out of a little piece of Delrin that I've got here. All right, the diameter of the shaft is a 151, so I got a 152 drill here, which will do. That diameter, 512 is what we need. Okay, I'm going to take off 92. Oh, it's got a lip on it. A lip. Woo! Almost made a mistake. Sometimes when you cut it, it leaves a little lip on the end, and you go and try it on the. You try it, and that lip catches and won't let it go up in there, and you make a mistake. You take some more off. And, woo! And it reads right on the money. Oh, yeah, it's a little too tight. I want it a little looser. I'm going to take another 1,000. Another couple thousandths there. Oh, that's just perfect. Oh, yeah. That gives us our two little pieces. Now we have to machine the slot in there so that our gear can get it in there. All right, I've got it in the milling machine, and I've got it marked on there exactly where the center is. Then we have our gear. So our other gear will just go in that slot and get onto it. Now, we push our plug down in there, and that will support the back end of the gear. Okay, first I'm going to just clean the stuff, and then we've got to drill the 2 holes here to mount it. That's going to be a trick, because it has to be just right. I can make the holes a little large so that they can be moved to mount it just right. All right, now our mounting holes, I got them marked here. Just go ahead, just a little. Boy, they're close. I might have to machine that a little bit to get some clearance. Okay. See, that gives us a little clearance so that the screw heads will go down in there. All right, that's going to do it. See, we got our plug pushed down in there, and that centers the back of the gear, and we're set to go. See, now that'll mount on the panel, and that other gear will go in there and rotate. Okay, let's go put it in. Okay, we have our little adapter made here. That looks really nice. Alright, that fits on here, right in here. Okay, we need a couple screws. Alright. Look at that. Ha! Look at that. And that's got it. So we didn't have to have a cast part that was made out of pot metal in a weird shape to hold all that, which would have been no way in the world we could have gotten. Okay, the next thing we have to do before we forget, we have to solder these wires back onto the tuning condenser. Alright, that turned out very, very good. Okay, now, one of these two is going to be the power tube. Okay, that's the speaker. That's going to be the... Okay, so this one's going to be the 71A. Okay, I'm going to write that on there. Okay. Common sense says to go ahead and test this thing before we put it back in the box. Let me think a minute. Yeah, that's right. We cannot work on it because to put it in the box, we have to put the bottom on it, in which case we can't get to anything to work on it if it doesn't work. Alright, so let's hook it up and make sure that it works. Alright, to do that, first we shall plug in some tubes. Okay. I'm surprised that none of these wires are skinned if this has been tested. I am doubting that this radio has been tested. I have a feeling that whoever was restoring it had it break before they tested it, and they just said heck with it. So this thing may not be in working order. All right, we need speaker and power supply. Okay, we'll use our good old radiola horn and our good old power supply. Okay. Okay, let's see. Yellow. I'm going to say yellow. All right. So what I'm going to do, I'm going to put a little piece of wire on the antenna one so we can just clip onto it. All right, now resume. Okay, I'm going to hook that to 68 volts. Okay. Now watch out, you get shocked here if you don't pay attention. Okay. What we do is put a bypass condenser on the third one over. I got one modern one in there already. We may as well use another modern one. You don't normally have to worry about the oxide on brass during your lifetime. But this radio is close to 100 years old. Most people would die before this radio disappears. You know, people aren't going to live 100 years. So, you know, in your lifetime, the brass is probably not going to form enough oxide to be a problem. But when you got a radio that's 100 years old, that's older than anybody. You know, everybody that ever saw this radio before is dead now. They're buried, gone. They didn't have any trouble with the corrosion on the terminals, because when the radio's 10, 20 years old, there's no trouble. The brass will go 20 years without building enough oxide to be a problem. All right. Woo-hoo-hoo. That sounds good. Okay. Okay, so it's just the adjustment of all these controls on the front here. I don't have any instructions on how these are supposed to be set, so it's just a matter of playing. And I was just poking around, and it started working, and there wasn't anything wrong with it. Okay, so we've got success. It was just mechanical, was all that was wrong with it. All right. Well, now we've got to get the box put on it. These are not practical radios. They're just to demonstrate. And you know, if you want a practical radio, you get you a nice modern solid-state transistor set. And these are just for they're to show off to people if they want to see what an old radio was like. All right. It was just a nightmare of mechanical to get it all working. Okay, now the cabinet. Okay, I'm going to get rid of the power supply and stuff so we have some more room. We'll put this on first. then put the cabinet on. All right, that gets the bottom on there. Okay, now we can put the cabinet back. Okay, that goes. There. Okay. There we go. Screw. Screw in the hole. All right, that's 2 of them in. Okay. The screw goes in. All right. Screw goes in. Oh my gosh. That is so amazing. You know, when you get them just lined up just right, they go right in. One way or the other, it's ridiculously complicated. They should have just had a threaded plate there and just stuck it right in there instead of these little rinky-dink clips. I don't know. Okie doke. There we go. Okay. Now, 71A goes here. 01A. Here. Okay. There we go. Then this one. Condenser turns just beautifully. Oh man. Okay, and then these go to here. Okay, we go all the way around. Okay, and then that one. All right, now that gets those put on there. Our mechanics all works perfectly. Okay, and this works perfectly. Okay, that's it. And here is our cover. Just goes right on there. Okay, I'm going to go ahead and leave this in there. And that's our Bandbox Junior. Just beautiful. Absolutely beautiful. It's probably somewhere around $500 radio. You know, all restored and working now. Okay, that'll go back on the shelf up in the attic. It'll probably sit there for 10, 15 more years till I croak. Somebody will inherit it, and it'll be a nice working radio. Okay, that's it.